I put it there. I don't have. Oh man. This thing here. Wait. Okay, much better. Good. Don't forget getting your charger back before you leave, okay? Okay. Okay. No, can make it work, I guess. All right. I don't know how much, to be honest, we can cover today, but I just I'll do my best, I guess. I'm just gonna go over the things that you really need for this course from CSC 271. Okay. So when we talk about object-oriented programming, maybe I can also use my thing so I can record things better. Oh, that's too as much. Okay, sorry. Switch to audio. Okay. 1, 2, 3. Sound volume. Input. Go all the way up. Okay, good. Here is my area. All right. Good evening. Like I said, I don't know how much I can cover. I just try to just go over some of the things that we basically need more in this course. Hopefully that would be enough. It should give you enough so you feel comfortable with everything that you see from now on in 274. And hopefully that helps you a little bit. Okay, go away. I don't want you here. Can I? Okay, I guess I can do it. All right. So when we talk about object-oriented things, there are four concepts that you understand. These four concepts, you understand the whole object-oriented thing. That's it. Okay. Just these four concepts. I'm just showing three. Sorry, that's four. Four concepts. Um, these four concepts, it's just the whole idea of object-oriented programming. It doesn't matter what programming languages you use, doesn't matter. All of them are following these four. Well, in some other programming languages like Python, some of these concepts are just so mixed up. That's why we're not teaching 271 or object oriented programming in Python anymore, because you can do things wrong in Python and everything still works. But Java strictly follows all these rules. That's why Java is good for teaching object oriented. Okay, the first one should be very clear: encapsulation. Okay, the whole idea is that whatever data that you are trying to create, okay, so for example, you are trying to create a data type about a car, about a monitor, for example. So you always want to hold two things about the data type that you are trying to create: the data related to the monitor and bunch of methods that allow you to work with that data. You have those things, now you can create any type of object about any subject. Okay, so let's just start with the monitor, since I already mentioned. Okay, let's think about the data that we want to hold about that monitor. Let's say it's a size, let's say it's a brand, let's say it's the qual like the pixel quality, how many ports it has. So you pick what type of data you want to hold about that monitor that you want to create as data. So all those data that you pick, now all those data is going to be your instance variables. Okay, so your instance variables are the part of your class that holds all the related data about like every monitor. Okay, for example, you pick the color of it, the size of it, what brand is that, is it the curved one or is it the flat one, is the wide one or is it tall one. So all these things that are holding some information about the monitor, now you define them as your instance variable. Okay, and then for you to be able to work with that data, for you to be able to work with that, with those instance variables, you just add a bunch of methods. Okay, so for example, you get the size of your monitor and you get how many ports you have, and you can say like, okay, this monitor is, the price of this monitor is this. Or for example, you, based on the data, you have a method that tells you whether or not that monitor is good for playing games. So for example, you can change the setup of like the audio quality of your monitor. So those methods are just there, so you can call those methods to work with your data, which are the instance variables. So we gather all those stuff, we just put them in one class. That's the whole idea of encapsulation. So we encapsulate everything related to that data that you're trying to create. We just put them all in one class. That's the whole idea of encapsulation. You've seen it, like we define classes, we define, for example, like array list, or for project one, you define the content one. So it has some instance variable and then bunch of methods that allow you to work with that instance variable. Does it make sense so far? Are we good? So that's the whole idea of encapsulation. You just gather everything you need about a specific type that you're trying to create. You just put them in one class, instance variables, bunch of methods, and boom. Now you have a class that you can use actually to create objects from that class. That class becomes the blueprint of your type. Now, using the keyword new, so every time you see in keyword new in Java, that means you're trying to create an object. So now from that blueprint, from that class, you can create multiple objects. And each one of those objects can actually have the same data as your class and can have access to all those methods that you added to your class. Are we good with this one? Are you sure? Okay. The next one, I'm just going to go to the inheritance. Let's just forget abstraction for now. The inheritance actually, it allows us to actually organize all these classes that we are making. Okay, so for example, depends on the idea that you're trying to create. Like it used to be, okay, I want to create a class about all the animals. So you create a class that has all the informations about animals. Um, and then now you want to create a specific class about dog or cat. Now you have to create a new class with the same methods and kind of same instance variables. But object-oriented programming allows you to say, okay, all animals have a name, have a color, and something. So you define one class and you put everything that is common in all animals in one class, and then that's become your parent class. And then other classes can actually inherit from that animal and add something to it. So now you can actually create a class called a dog, and dog class is going to become a child class for that animal class, and now you can inherit everything from the animal one. So for example, all those names that you had already inside the animal, and now you can also have more things inside your dog class or cat class or stuff like that. That's the whole idea of inheritance. Like another class can become a child of another class, and it works the same way that it works between human. Like you inherit something from your parents, that means you have access to everything they have, right? You inherited your car or a house or whatever. They allow you to inherit from them, and now you can actually use them in your life. It's the same idea. Whatever your parent is providing, once you extend that class, that means now you are a child of that class. That means you have access to everything from the parent class. The polymorphism one, it sounds scary, but it's actually super easy. So the polymorphism is like that. So you inherit your father's car, you can still drive it with the way it is, but you're like, you know what? I don't like this color. So you can actually change the color. You can paint it again or you can make it your own. Okay. And that's the whole idea. Or maybe like you inherit like a piece of dress from your mom and you don't like it, so you want to make some changes here and there. Okay, so if you know how to do it, so you make it your own. So that's the whole idea of polymorphism. You inherit some methods and instance variables from your parent class, but you get to override it and make it your own. Okay, so that's what the polymorphism is. So for example, you get, I don't know, like a add class. Your parent class already has like an add method, but your parent class, the way it adds it, it just adds it with with no message. But now you wanna override that add method. So as you're adding something, adding some element to your whatever you're supposed to add, you also want to add some message to it. So you can do that. So now you can override those methods and just make it your own. That's the whole idea of the polymorphism. Okay. Are we good so far? Inheritance, polymorphism, and encapsulation, which should be obvious. Um, for the abstraction, let me show you a little code. It makes more sense if I just show you some codes. Um, can I stop sharing and then switch to VS Code, I guess. Oops, go away. Go away. Okay. If I can just drag and drop and bring it here, it would be much better. Okay, it's the same example that I just mentioned. Um, let's say we created a class for animals. So we think all animals that we have should have their idea of their own, like what's their breed, what's their age, and we have constructor. We have some getter methods. These getter methods are the methods that provide the value of instance variables. So we always start them with get. So we call them getter methods. So for example, get age, what it does, it actually returns this instance variable age. Um, and I will talk about like what the protector is and private and public stuff. So these are getter methods. They're returning the same value of that. And then take to the vet. I have this method inside that. We should take all animals to the vet. We should take, they should clean all the animals. And we also have the two-string method. Does anybody know what the two-string method does exactly? You've seen it a lot, probably. So the two-string method is responsible how like when you create an object from this animal class, and then when you say, so for example, you create an object from this class, you call it, I don't know, A, and then when you say system out print line A, okay, the first thing that Java does, Java going to go through the class, is going to look for the implementation for the two-string method. If you do have the implementation for the two-string method, it's going to run that one as a result of printing an object from that class. But if you don't have implementation for that class, it's just going to shows you a bunch of weird numbers, which is the memory location of that object. So the two-string method is responsible for how the output of like when you print an object from this class, how the output should look like. And these are what we call them formatting things. And the way the string format works is that we use these percentage things, we call them specifiers. Okay. So I just completely moved to another topic. But since I'm on it, let me explain like what this thing is, because I know many of you don't know like how to use these specifiers as well. So this is what we call the specifiers. And we have specifiers or placeholders for different types in Java. So for example, here, what I'm trying to print is, this is what I'm trying to print right now. Some numbers, and then I want to add a tab, and then some messages, whatever that is, and then I want to add a tab, and then I want to print some value with only 2 digits after the decimal point, and then I want to move to the next line. Okay, so I want to print something like this, but I don't know what this number is. I don't know what string value I have here. I don't know what double value I have here. So I use some placeholders instead of those. And different types have different placeholders. So here, for example, I say, I don't know what integer value I want to use here. I'm just going to pass some integer values here later, but I'm just going to put a placeholder for integer value. So the placeholder for integer value is %d. Okay, and then later on, I'm just going to give this placeholder like some integer value. And then I need a tab here. So I can use \t. \t gives me like 4 spaces, 3 spaces, depends on what type of screen you're using and everything. It just adds a tab. And then I also want to print some string values here, but I don't know what that string value is. So I'm just going to use the placeholder for a string, which is a %s. Okay, and then later on, I'm just going to pass in pass some string values to this one. And then I need more tabs here. So I'm just going to use \t again. And then I need to print some double values here. So for printing a double value, the placeholder is %f. Now I can also format how many digits I want to have after the decimal point. So I add a decimal point right here. I add a decimal point right here between the percentage and f, and then I add a number. I want to say after the decimal point, I will only want to see like 2 digits. So that's it. And then I'm just going to, with the same order, you need to pass some values. So for this one, I'm saying, okay, later on, whatever the ID is, I'm going to pass that. So whatever the value of this ID is, it's going to go sit on this placeholder. Whatever the breed is going to go sits on this placeholder. And whatever the age is, it's going to go sits on this placeholder. So that's how the formatted print works. And you also need to use that for implementing the toString for your project. Does this make sense? Okay, good. All right, going back to the original topic, which was defining that thing. Okay, so now I have this class as an animal. It has some stuff in it that I think is just common in all animals. And then I can have other classes, define them to become a child of the animal. So as soon as I say cat extends animal, that means now cat is a child of animal. That means whatever public I have inside the animal, now I can inherit all of those, all the instance variables, all the methods, everything. Okay, everything that is public, now I can use it from my parent class. We call the parent class also a super class. I will talk about the super in a bit, but we also call the parent class super class, and we also call the child class a subclass. Okay, so you will hear these two terms a lot in object-oriented programming: super class and the subclass. So super is the parent one. And then, so here is the constructor for this one. And that was another thing that I saw many of you had issues with. So now you want to initiate the constructor inside the child class. That means the first thing that you want to do, the first thing, like the first line inside the constructor that you have inside the child class, that means you need to call the constructor from parent one. So in this case, we had some instance variables, ID, breed, and age, that should be initiated inside the parent class. So you're not gonna do them manually inside the child one, inside the cat one. What you're gonna do, you're gonna call the constructor inside the parent class, and that one takes care of it. So for calling the constructor from the parent class, you use super with parentheses, and that means now you're calling the constructor inside the parent class, and it must be the first line inside your constructor. You cannot add this like in the second line or third line. It must be the first line. So right now, this line is calling the constructor inside the parent class, and as you can see, I am passing an integer as an ID, and a string, and a double as the age. So what happens right now, Java going to go inside the parent class, looks for a constructor that gets an integer, a string, and a double. There we go. That's the one. So it's going to call this one right there. And then you get to initialize other instance variables inside this class, if you have any. In this case, we have this instance variable color inside the cat. So now you get to initialize that one after calling the super. Again, the super must be the first one. If you have more constructors, okay, something like that. Like I have another constructor. This constructor only gets one integer and one string. So in object-oriented programming, the goal is to reuse the code as much as you can. You have other constructors, okay, that takes care of initializing the instance variables for you. You want to add more constructor, that means all you need to do is just call the other constructor, okay? And we use this with parentheses. So as you can see, I am using this with parentheses. So that means I am calling a constructor inside the same class. And since I only have the ID and the breed, I'm using some default values for the age and some default values for the color. So now with this line, what happens is that it's going to look for a constructor inside this class that gets an integer a string, double, and another string. There you go. That's the one that I have. So it's going to call this one with all the values that we are using here, and the other constructor is going to initiate and initialize all the instance variables for me. Another example, like I have another example, another constructor. This one gets an ID and age. So I'm just going to use some default values for the breed and the color, and then I'm just going to call the other constructor again, and it's going to take care of everything for me. Are we good? Okay. Are you sure? Stop me at any point if you have any question. Okay. So that's about using super and this. So if you see something like that, don't panic. Basically, you're calling constructor either from the parent class or inside the same class. And that's something you should do. And if you want to do that, that should happen in the first line inside the constructor. Okay. Like you cannot move this one to another line or anything. Sorry, don't mind these errors because I didn't open any project or folder. That's why I'm there. I have like that red underline under them. And then I have this method. As you can see, this method belongs to the cat object. And I'm actually printing some message, and I just print the breed. I can also, sorry, man down. Okay. I can also call method. I don't need to use super here. Okay. Even if I don't use super, that means I have access to all those methods from my parent class. But if you want to directly mention and specify, you know what, I am calling a method from my parent class, you can use super. This is super period. This is super dot. This is not super with parentheses. Super with parentheses, that means you're referring to a constructor inside the parent class. But you just use super dot, it lists every public in your parent class that you can call actually from your parent class. And get read is one of them. So I just added that super thing that show you that I'm calling this method from the parent class. And then I want to overwrite the toString method. That's the whole idea of polymorphism. I have the toString method that prints something inside the animal. I do not like it. I want to make my own toString. So all I need to do, I just add this add overwrite at the top of my method. And there we go. Now this is overridden from the parent class. So now if I create a cat object, and I call and I try to print my cat object, it's going to run this one. If I remove this one and I create a cat object and try to print that, it's going to call the toString that I already inherited from my parent class. Okay, that's going to be the difference. Does it make sense? Are we good? Okay, let's jump over to the equals method. So the equals method, I guess all these years, the first question that I got from implementing the dot equals method is that why the parameter is object. Am I not comparing like two cat objects in this case because it's inside the cat class? Why am I getting like a parameter as an object? Okay. So every class that you make in Java, every class by default is a child of another class, which is we call it object class. All right, let me just load that one up so you can see what I'm talking about. Java API 23 object. Okay. What is the thing? Can I maximize this? Okay, so this object class is the parent of all classes. You open your VS Code, you start writing a class, by default is a child of object class. We call this one also God class. Okay. By default, it's always a parent of all classes that we make. Um, look at the methods that this one has. Look at the list of methods that this one has. There we go. The clone method you need to implement for your project, right? And your returning object. Do you see that? The clone method returns object. That's why. That means every time you're implementing the clone method, basically you're overriding the clone method from this God class, which is object. Same thing, like you're implementing the toString method. Where did it go? You're implementing the toString method. That means you are overriding it from this God class, which is the object one. Dot equal method right there. That means you want to implement the dot equal method. That means you are overriding from parent class. Does it matter if I just go back and just implement the dot equals method with a different parameter type? It's fine. It works. You're not going to end up with any compilers or anything. But if you use other Java libraries that they need to compare, like your cat objects, they're going to look for an equal method with this signature, with this method signature. If they cannot find it, they cannot compare like cat objects. Okay. So if you want other classes to be able to compare objects from the classes that you make, you have to implement dot equals method and dot compare to method with the specific signature that I just explained for the dot equals method, and I will get to the dot compare to method as well. But as you can see, dot compare to is not here. So that means we need to get the dot compare to method from somewhere else. But that's the main reason you have the dot equals method um, 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 has to have like a object as a parameter. Same thing with the clone method. That's why the clone method must return an object. So other classes actually can see this and can actually use those things. Are we good? Okay. Let's go back to how do we implement dot equals method. So now that we know the dot equals method must guess an object. So every time you want to implement dot equals method, you need to do three things. Is it three? Yes. You need to do three things. Okay. For those who just got here, I was just saying object oriented is four things, and then I realized that I'm showing three. So this time I'm showing it right. So number one, make sure the given object is not null and it's something that we can use. So if it is null, or this given object is from some object that is not for us to compare with our own object, we're going to return false immediately. So if it's null, or if it's not the instance of this cat class. So this instance of, you might think is a method, or you might think it's a class or anything. This is actually an operator, like a plus minus multiplication, okay? This is a Java operator. The instance of returns true if these two classes are from the same family, or kind of they're like kind of like in the same hierarchy of the families. Okay, one of them could be a parent, one of them could be a grandchild, or they could be even cousins or something, like they have same parent classes. As long as they're coming from the same family, this instance of returns true. And as long as they are from the same family, that means we can actually compare some values inside those objects. So, but if it's not from, that's what the not thing does. Okay. So if they're not from the same family, so that means the instance of is not true. that means we cannot compare them. So we're going to return false immediately. Okay. That's number one thing that you should do inside the dot equals method all the time. It doesn't matter where you are defining a dot equals method. You need to make sure these two things. So in this example, I am inside the cat class. That's why I use cat object here. I use cat class here. So if you're inside content class, you need to use content here. If you're inside joke class, you need to use joke class here. Okay. Number two. Now that you know the given object is something you can work with, you must cast it to the object of the same class. So you cannot just use object as an object type. Okay, like I try to call like an instance variable on this guy. It's going to give you a bunch of errors. It's like, what instance variable you're talking. The object type itself, it's so general. It can be converted into anything. So now you need to cast it to a cat type. So now you can actually work with it inside this class. So number two, you need to cast it to whatever class that you want to work with. So in this case, I want to create a cat class. So I'm going to cast it to a cat. Are we good? Number three, now you have two things. Now you have two objects to compare to each other to see whether they are equal. Sorry if I have a typo. I'm not good at typing things. So what are those two objects? One of them is just this guy. The other, one object is other. The other one is this, whatever you have inside this class, all the instance variables and everything. So now you have two objects to compare them to each other. So as you can see, in this case, two cat objects are equal if they have the same breed and have the same age. And look how I'm getting those breeds and age. I'm getting the breed from the other, and I'm getting the breed from this. Same thing with the age. I'm getting the age from the other, and I'm also getting the age from this. So now you have two objects to compare them to. So number three, for this part, you do the actual comparison. And whatever you are trying to compare to each other, and based on that, you want to say, okay, based on, so in this case, I'm assuming two cat objects are equal if both have the same breed and same age. Just a preference. Okay, so that's it about implementing dot equals method. Are we good? Any questions? No? Are you sure? Okay. So also about the polymorphism. So the polymorphism is just overriding a method from the parent class. It could be anything. So in this case, I'm just overriding the toString. That's the whole idea of polymorphism. Okay. I think I also have like a dog one. There we go. So same thing. I don't have any instance variables in this one. Yes. Yes, in the newest version of Java, in the newest version of Java, it's okay if you don't mention it. So Java gonna realize that, okay, since this method was already inside the parent one, that means you're overriding it. But it's always a good practice to be clear about your code. Like if you're really overriding something, so please add that add override clause to your method so you can show whoever reads your code that you're actually overriding this from somewhere else. But in the newest version, especially these versions that we are using, it's okay if you don't use override. You're not going to end up with any compiler or not even a warning. Java going to take care of everything. No, that's fine. That's fine. If you missed it, that's fine. As long as your code works and everything, that's fine. Okay, so, and I'm overriding to a string again, and I'm also overriding the equals method. So this one is I'm overriding from the object class. So look how I'm implementing the dot equals method inside this one. Same thing. I make sure this given object is coming from, okay, this should be dog. Shouldn't be cat anymore. Sorry. This should be dog. I'm making sure it's coming from the dog family. If it's not, or if it's null, I'm just going to return false immediately. I'm casting it to a dog object so I can work with it. And for me, two dog objects are equal if they're from the same breed. And then I do the actual comparison here to determine whether or not two dog objects are equal. And then there was one more thing that I needed to explain, the abstraction. Okay, that's the fourth thing about the object-oriented stuff that we need to talk about. So the idea is that, for example, here, as you can see, I am actually overriding these two, the toString method, both in cat and dog. Okay. Which means no matter what I do inside the animal, my kid's gonna change it, right? They're gonna make it their own. They're gonna print different things. So one solution is that you just don't implement it at all. Okay. So basically, one solution is that you just get rid of the implementation inside the parent class. Once you do that, so that means there are some cases you want to make sure your child have it, but you don't know if the way that you're having it is a good way for them. So you just want to let them to have them and just implement them in their own way. So for those cases like that, now you just define things as an abstract. And now basically what you're doing here, I don't know why I'm getting errors, but that's the way of doing it, okay? I don't have everything set up correctly. So now you just define this method as an abstract. That means you are not implementing it. You just want to make sure your child have it. Basically, you're enforcing them to have some implementation for it, and now they get to implement it in whatever way they want it. They want to implement it, okay? If you have an abstract method inside your class, that means your class is not a normal class anymore. That means your class now is an abstract class. Okay. So as soon as you have one abstract method, now your class becomes an abstract class instead of just a normal class. And that's the whole idea of abstract. Okay. So there are some stuff you want to kind of enforce to your child classes, to your subclasses, and you don't want to have any implementation for that. Basically, your child get to override those in whatever way they want. Okay. There are some differences, like huge differences between normal class and abstract class. As soon as I change this normal class to an abstract class, that means now I cannot create an object from the animal. Before this, I had implementation for all methods and everything. That means I can actually say animals, give it a name, equals new animal. That means I can create an animal object. But as soon as I make one of my methods abstract, which makes my whole class abstract, that means I cannot create an object, animal object anymore. And the reason for that should be super obvious because one of the methods does not have an implementation. So Java is going to be confused. Uh-oh, what should I do when we get to the toString class? So as soon as you try to create an object from that, it's going to throw a bunch of errors at you and it's going to be mad at you. That's the only big difference between a normal class. So you cannot create an object from an abstract class compared to a normal class. That's the whole idea of that one, that abstract class. Any question? Yes. You're good. You can have constructor class. Why do you need a still constructor class? Because when your children are inheriting things, um, we still need to somehow initialize these instance variables inside the parent class, right? So when your children are inheriting things from the parent class, we still want to be able to call the constructor from parent class to take care of initializing those instance variables inside the parent one. So you still need constructor. You don't have to have constructor, but you can have it. And it's not, but it still doesn't mean that you can create objects because you definitely have some methods with no implementation. The next question is that how many abstract methods are you allowed to have? You can have one, you can have 1,000. Okay, the minimum is one, and then you can have more, as many as you like. The good thing about the abstract class is that you can have your own implementation for some methods, and then you can leave you can have some methods with no implementation. Another idea that comes with the abstract idea for object-oriented programming is that, you know what, I just want my kids to have everything that I have. I do not want to implement any of those. Okay. I'm just gathering everything for my kids. I don't want to use them at all. I'm not going to implement anything. I just let my kids to just implement all those stuff. Does that sound familiar? We already did it in the class. So if you're not implementing any of the methods, now your class is not a class anymore. It's what we call it interface. Okay. Like a collection, like a list one that we implemented in the class. So those are not a class anymore. Okay. Like in the header, you don't even mention the class anymore. But for this one, you do mention the class, right? So the abstract is still a class. But if you don't want to just list a bunch of methods so other classes can inherit those and implement those, now you just switch to interface. So the whole idea of interface is to enforce some concepts. Okay. So basically, you're forcing whoever is your child classes to implement everything that you have in your class. And now you're dealing with interface. And interface cannot have a constructor, cannot have like any instance variables. The interface is just a header, interface header, and just list a bunch of methods. That's all. That's the difference between an abstract class and an interface. So in interface, none of the methods should be implemented. Basically, you cannot implement anything, no constructor, nothing. But in abstract class, you can have instance variables, you can have constructors, you can implement some of those methods, but you still need at least one abstract method. So now your class becomes an abstract class. Does it make sense? Okay, so let's look at an example. I think I have one. So all those things that I just explained, they're right here. So the abstract method. So for the abstract class, you cannot make an object from your abstract class. So abstract methods have no bodies. Abstract class is the class with one or more abstract methods. You can read all of these if you want to. I'm not going to look at this one. So this is an abstract class now. I have a constructor, and then I have one abstract class. This is an animal. All animals can make some sound. Um, and we also implement this method, show name. And then we have dog that extends the animal. Um, and they have to overwrite the make sound. Okay. So as you can see, now this class must overwrite the make sound method. And now the dog wants to bark to make sounds. Or another class, I think, did I add a cat one? No, I don't have a cat one. But that's the whole idea. Now, this one is a child of the animal. They must have implementation for all those abstract methods. Does it make sense? Are we good? So that's the whole idea of object-oriented programming. There are three more things that I need to mention. I have a bunch of slides here. Let's just switch to those slides. Okay, it's right there. Okay, so that's the whole idea of encapsulation, abstraction, inheritance into polymorphism. You understand these four things, you understand the whole concept of object-oriented programming. Okay, so like I said, you can have parent classes, and that parent classes can have more child classes, but all classes that we make are become a child of this guy, the object class. Someone might ask, okay, do we need to import this class every time we start writing a class? Not really. So every class that comes from this package, java.lang, you do not need to import it. For example, the string class, you just start using it, right? Comes from this package, java.lang. So you do not need to import it. The math class where you call the sqrt, abs, all those methods, comes from the same package. You do not need to import it. So that's why you're not importing it. By default, you can just use it knowing that your class is going to be the child of this guy. Okay. Some of you did not know how to understand the UML. It's super easy, guys. So the whole idea of the UML is, or we can actually explain all the details of the classes and methods and the relationship of those classes. Okay. So there are a couple of signs that you need to understand. So plus we use to show this is a public. If it's private, we use dash. If it's a protected, we use hashtag. So if something is protected, that means only classes in the same package can see it and can use it. Okay. So for example, you want to define an instance variable or a method, your child can use them. So if you define it public, that means everybody can use it. Okay. Whoever, even from different packages and different folders. But you only want to make like a method or instance variables available for the child classes in the same package. And when I say package, it's a word that you feel like you're moving to another planet. The package is just a folder, okay? The package is just a folder that allows you to organize things by just putting things in different folders. Like the package is just a folder, okay? So as long as you have all the classes in the same folder, that means if you define something protected, all those classes can see it, can use it. That's about the protected. Package access. I don't think we have time for me to go over that. I don't think we're going to use it in 274. So let's just forget that. And always we point towards from the child towards the parents. It usually for some reason, students always do the other way. They always point from the parent to the child, but that's not the case. You always want to point from the child to your parent. So for example, here, looking at these instance variables, We also specify what, yes. Um, I don't know really. Um, I don't really know why we're not going the other way around. I never looked it up. That's a good question. Yeah, yeah, that's the exact same reason like the students use the other way. Um, there has to be a reason for it, but I don't. I'm not aware. I've never looked it up. It just made sense to me for some reason. I don't know why. Maybe I just saw it enough, so I got used to it. But yeah, sorry, I don't have any answers for that. My bad. We can look it up. Um, but I'll look it up and I'll talk about this one in the class just to make sure everybody has a good understanding of like why. Um, but just keep that in mind. If you're supposed to read a UML, which you are in this course, 274, we always point from child classes to the parent one. Same thing with when you are pointing to an interface. Um, for interface, we use dashed line or dotted line. We don't use a straight line. Um, so if you look at the UML that I use in project one, I'm using dotted line to point to the interface, right? That's the difference. Um, so for example, I have like an instance variable which is protected. It's an integer. Another one is integer. Another one is integer. Another one is a string. And then these are the list of constructors that I have. And we also specify the type of parameters and everything. So for example, look at this one. I have get area in both triangle and circle. That means I'm overriding the get area inside the parent class polymorphism. Um, so yeah, so that's the whole idea of using UML. It should be pretty straightforward reading the UML. But here's the thing, like if you're given any UML, that means your class must be implemented the exact same way, like all those things that are mentioned inside the UML. You do not want to add anything extra, and you definitely do not want to miss anything from the UML. So if you're giving any UML, that means your class look exactly like the UML that is provided. Okay. What else? This and super I already mentioned. So for example, you can use this with parentheses to call other constructors. So for example, here I am calling like this constructor using this, or here I'm calling the other constructor using this. Um, Same thing with the super. You want to call a constructor from the parent class, so use super, and it has to be the first line of your code. Okay, what else? What else? Polymorphism, I did talk about it. Okay, upcasting and downcasting. Okay, casting in general. Going back to, I don't know, let me just go back to the codes. So going back to this, okay. I can create a doc object here. And now if I just pass this to animal, so as you can see, from a child, I am going one level up to the parent one. This is called upcasting. So that means now I have an animal object with all the implementation from the dog. Like if I'm overriding anything inside the dog class, that means now those implementation is going to be used inside the animal class. The same way we go from fixed size array list to a list. That means all those overridden methods goes with it. Okay. So this is what we call offcasting. From a child, you go one level up to the parent. This is what we call offcasting. Offcasting is always safe. Going and visiting your parent is always safe. Just give it that, like, memorize it this way. Okay. It's always safe to go see your parent. Okay. And use the stuff that your parent has. It's always safe. So offcasting is always safe. But downcasting, now I create an animal object. Now I want to cast it to a dog or a cat. Okay, Java gonna be confused. Like, especially if you have some instance variables inside the cat or dog that we didn't have inside the animal one. So it's not a safe thing to do. You only do downcasting if you're 100% sure you're not going to cause any issues. Okay. One way that you can make sure that you're not making any issues by making sure they are coming from the same family. So if dog is if A is an instance of dog, so that means if they're from the same family, now you can actually go ahead and just do the downcasting. Sorry. In this case, we know they are coming from the same family. So when you want to do downcasting, you need to know it's a tricky thing. Java usually doesn't like downcasting, so you really need to pay attention to details of those classes, and you definitely want to have a condition like that to make sure that downcasting is safe. Like, you cannot downcast from dog to, I don't know, like another class, I don't know, like car object or something. Okay. So you need to make sure it's possible. So be careful with upcasting and downcasting. So now, if I just do this downcasting, now that means I only have access to the methods that I have inside the dog class. Everything that I already inherited from the parent one, they're all gone. I only have access to the things that I have inside the dog class. Yes. No, 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 no. If you don't have that condition, your program, and if you're not doing any safe casting, your program crashes because of exceptions. You're going to end up with runtime errors. You're not going to get any warning or anything as you're compiling your code. Compiler does not check this type of stuff. You run your program, and all of a sudden, boom, your program crashes because of some runtime errors. So we add these conditions just to prevent that, to prevent runtime errors. That's the whole idea. Are we good about upcasting, downcasting? Does it make sense? Are you sure? So we're going to do a lot of upcasting and downcasting in 274, like going from list to an array list, from array list going to collection, from collection going to fixed size array. We do a lot of upcasting and downcasting. If you're doing downcasting, going from parent, from the child, you don't want to know what you get. Sometimes child are so generous, they let you to just have everything. They just let their parents have everything. Um, but you kind of want to make sure. So having a condition like that to see if you're welcomed or not, um, you it's good. Okay. Yeah. Um, what else? Let's go back to those slides. Oh, okay. Dot equals, I just explained. Okay, one thing about the abstract class or interface, both are the same. Um, we show abstract or interface classes in UML differently. So basically, either we really mention this is the abstract or interface, which you saw that in the UML in your project one, I am explicitly saying this is an interface. Or we use italic font for it. As you can see, this thing is tilted to the right a little bit. That means I'm using italic font for it. So you see an italic font somewhere, that means it's an abstract method or interface. But it's not very clear way of demonstrating whether or not the class is abstract. So it's always better to explicitly mention this is an abstract or this is an interface, which is something that I did in the instruction for project one. I explicitly mentioned this is an interface. It's a better way, but you need to know that some people use italic font and you look at it like that and nothing, they all look the same. So you really need to pay attention. Oh, look at all those methods. Look at all these methods and the thing itself, they're a little tilted to the right. So that means italic font was used for that. What else? What else? What else did I promise you to cover? So that's the whole idea of object-oriented programming. You understand those, you understand everything. So now it should make sense, like why I defined the collection as an abstract. So those collection and lists are basically some concepts. We call them abstraction, right? In 274, we call them abstraction data type. So basically, there are some concepts that we are enforcing the child classes to implement them. And now we call those child classes data structures. They have the actual implementation for those interfaces and everything. JUnit, that was another thing that I wanted to talk about. You raised your hand. Was it something else? Yeah, what is it? Okay. Go ahead. What is it? Like, is it about? Okay, what is it? What should I cover? Oh, I forgot about that. Okay, Jesus. Okay. Okay. Compared to good. Just let me know if I'm missing anything. I appreciate it. So compared to. Okay, let me switch to code again. Okay. So the compare to method allows you to compare two objects from your class. But the difference between the dot equals and compare to is that dot equals only tells you whether or not two objects are equal. But that's not enough for you. What if you want to know if one dog object is greater than or smaller than the other one? Why do you need to do that? Because as you want to sort a list of dog objects, or as you want to sort a list of cat objects, we should be able to compare two dog objects or cat objects. So in Java, we implement dot compare to method for it. Okay. And to enforce other Java libraries to use that method for comparison, we need to enforce some concepts on our class. And that concept is called comparable. So that means you want to implement dot compare to method in a way that other classes, Java libraries can use it. You need to mention that I am implementing comparable, and what I'm trying to compare in this case is, for example, dog. Okay. Okay. So as soon as you say this compatible is just an interface, it just enforces you to implement the dot compare to. And now that means you must implement the compare to. And unlike the equal one, since I mentioned that I want to compare dog objects, so now look at the parameter for the compare to, it gets a dog object. Okay, it does not get an object or anything. Um, One question that you might ask here, what's going to happen if I just don't have this? Is it going to be a problem if I just implement the compare to method? No. Like you can actually get rid of that thing and you can implement the compare to method and you can actually use this to compare two dog objects. But the problem here is that other Java libraries now does not follow your compare to method. Okay. They don't see it. So for example, you want to call the sort method from the arrays class and you want to give it like a list of dog classes. It cannot sort your list because it does not know how to compare dog objects. Why? Because it's going to check the header of your dog class. And if you don't have that implements, if you don't have this, now it's going to assume that you do not have the implementation for the compare to method. Okay. So for that reason and that reason only, you must mention this in your class header if you want other Java classes from the Java library can actually compare objects from your class. Does it make sense? Yes. Yes, I think the instruction is asking you to do that for project one. Yeah. I think the instruction has some explanations about it. Let me just load it up just to make sure. Okay, where is compare to? Was it the first one? This method returns a type positive. Did I not mention that anywhere? I'm pretty sure I did mention it somewhere. Oh, there we go. So the compare to joke method comes from the comparable interface, which you must explicitly implement in your class and mention it on your class header. Unlike that equals, okay. So what happens if you don't add implement comparable? So I'm specifically actually explaining this. What happens if you don't add implements.comparable? Your code will compile and run without errors, obviously. But Java utilities, which I meant like other libraries, won't recognize your compare to that you implemented. And because of that, like they cannot use it, they cannot compare. So basically, for example, you cannot sort a list of in this case, is it like a joke or content? So basically, like other libraries cannot see it. So it's always good to mention in your class header that you're implementing comparable. That's the whole idea. Um, Okay, so as you can see, the compare to method returns a number. Okay, and it could be a positive number, it could be a zero, it also could be a negative number. If it's a positive number, it means this object, whatever we are trying to compare to, is greater than the given object. If it's zero, that means they are equal. It works exactly like dot equals method. And if it's negative, that means this object is smaller than the given object. Okay. So for the compare to, we do not check to see if they are null or anything. Okay. That's just for dot equal one. So let's say two dog objects, like one is greater than the other one. What we have here? In this case, we only have names to compare to each other. Okay, let's say for this case, for this example, we check the length of the names. If one has a more length compared to the other one, we call that one greater than the other one. Okay, so in this case, now you just need to have bunch of if conditions. So if this dot get length, no, not get length. This dot name is a string, so I can call the length function on it. If this one is greater than the given object, I've been writing Python code, so I forgot. So if that's the case, I can say this dog object is greater than the other one. So I'm just going to return positive one. Okay. Any positive value. If it's any positive value, I'm just going to go with one. That means this object is greater than the given object. Else if it's the other way around. Okay, I am not recording this. Jeez. Okay, sorry. Okay. Else if this name. Okay, I already copied that. So now if it's the other way around, that means this object is smaller than the other one. So I'm just going to return any negative number. And if it's none of those, that means they're equal. So I'm just going to return 0. That's it. So in your dot compare to, you always need to return a positive number, a negative, and 0 based on different cases. So we always return positive value if this object is greater than the given one. This is just by the convention, okay? That's how we implemented the compare to across all Java library classes. Does it make sense? Are we good? Can we start talking about the JUnit stuff now? Okay, what else? Beef coffee. Oh, cool. Yes. Yes, for sure. Can I record the board here? I think I can. Okay. Okay, good. So for deep copy stuff, first we need to understand how Java holds and saves values. So you see all these professors draw things all the time, and you're just like, that's BS. We're just wasting our time. Not really. You cannot actually understand all these concepts if you don't draw things. The only way it's drawing things makes things easier to understand. So that's the main reason we draw things, especially for this type of concept. So Java holds objects inside the memory in a different way. So for example, and it doesn't matter what type of object we're talking about. Arrays are object, strings are object, cat is an object, car is an object, building is an object. It doesn't matter what type they are. It doesn't mean like because we are using a string or arrays more than other objects, now Java deals with them differently. No, Java deals with all of them the same way. So for example, okay, from here, it's in camera all the way to probably here. Okay. So for example, I say string, hi. Okay, sorry. What am I doing? Yeah, it's not that bad. Okay. So I say something like this. This thing has two parts. This is not a one expression. The part that actually creates the variable the parts that creates the object. I can also use this using this. I can also say new string high. I can also do it this. These are the same thing. In Java, you can also do this because it's a commonly used class. So they actually added more code. So when you do something like that, it works kind of similar to this. Kind of, not exactly. So this has two parts. So the first part creates a variable for you. So Java gonna go somewhere inside the memory, grabs the part of the memory. We called it S. It's gonna name it S because we called it S. And then this is the part that you create the actual object. So it's gonna go somewhere else. Creates that object, initialize it with whatever you want, and then whatever the memory location of this guy is, it's going to save it inside this one. Let's say the memory location of this guy is this. It's going to save it here. That means the variable is not holding the actual string value. It's pointing to it. Does it make sense? Same thing with other objects. Let's say you're making a cat object. Okay. Same stuff happens. Sorry, I have to clean this up. Oops. Let's say you have a cat object. Oh. And then you say cat C new cat, whatever. Okay. So, and this cat object, let's say it has like some instance variables. Right now, the name is like an empty string. The age is 1, and it also has bunch of methods in it. So right now, Java gonna go somewhere else, creates this cat object. Why? Because of this. This is the part that actually creates the actual object because of this new. And we also have a cat variable. So Java gonna go somewhere else, create this cat variable, and now whatever the memory location of this guy is, it's gonna save the memory location of that one. So now if I just do this, cat C2 equals to C. Can you guys see it? Okay. So now if I just do something like that, so same thing. This is the variable. So Java gonna go somewhere else, create C2, and then I'm assigning this guy to this guy. What this guy is holding is some memory locations. So Java gonna grab a copy of that and also gonna save it inside that. As soon as we save the same memory location, we transfer the same memory location inside this one. That means this one is also pointing to this one. This is what we call a shallow copy. You might think you are getting a copy from C2. And the question is, why should you think like that? Because you're already tricked as you were working with the primitive types, because you did the same thing with the primitive type. Now you want to get a copy of that one, you just say int n equals to num. Right? With the primitive types, it's a different story. This is actually like a separate copy, because with the primitive types, variable or the values. Variables and values are the same thing. Okay? Unlike here, variables are not the values. They're pointing to the values. So with the objects, it's a different story. But with the primitive types, it's a different story. Like, this is what happens if I just do that. So Java gonna create this variable num, and look at that. the num is value 10 right there. And once you do something like that, this is what happened. Java going to create another variable n, and then it's going to look at this one to see what value this one is holding. This one is actually holding the actual value. It's going to get a copy of that. It's going to save it inside this one. Now they are same copy and they're totally independent from each other. You change one of them, has no effect on the other one. So this thing that you do, that you have done a lot in Java, makes you think you can do the same thing with objects. So you end up doing something like that, and then you change one of these, you're just messing up the other one. Okay. So the reason yes. Say it again. Oh yeah, is a hexadecimal, and I just use those numbers as just demonstrate this is the memory location. The memory location has a string in it. The actual memory location has a string in it. Has decimal numbers in it. It's a different thing. We can write a code to print some memory location so you can see like how they look like. No, no. So the variables are the values actually for primitive types. So in Java and other programming languages. So for example, you define something like that. Basically, what you're doing here is that you are just giving name to this value. That's what it means for primitive types. That's why we call them primitive types, because they were designed differently so they can be fast and more efficient so we can use them. And they're totally get saved inside the memory differently and all those stuff, just because we want them to be more efficient. So this value, basically, we just named it num. So they are the same thing. We say num, that means we're referring to the value. We don't use memory locations for primitive types at all. Did I answer your question? Okay. So I drew all this stuff so you can see we're dealing with a different animal here when we have objects, okay? And this thing, all these stuff are happening for some security reasons and everything. So some of you might ask, okay, why aren't we do the same stuff that we did for primitive types with these? This setup also has its own advantages, so it's not that bad. The only area that this could cause an error when we are dealing with copying stuff. Okay, so this is what we call shallow copy, which basically two variables are sharing the same object. This is what we call shallow copy. Basically, as you can see, this is not the actual copy. The actual copy is something like this. Totally different, totally independent from each other. You change one of them, has no effect on the other one. The question is, okay, how do I need to create a deep copy? So there is only one way and one way only. So you want to get a deep copy of this guy, you have to create a new cat object. So this is what you need to do. So this is no. So basically now, can you guys see it? Okay, I'm just going to continue here. Oh, they cannot see it. Sorry, guys. I'm just going to write it here. Okay, cat, boy, seat. Oh, I have a marker. Nope. All right. You have to create a new cat object. And all that matters inside the objects are these instance variables. These are the important data in each object, instance variables. So we get the name separately, we get the age separately, and we're just going to use it to create a new object. So now I'm just going to use, so here, it's going to be c dot name. I'm going to use that as a name, and c dot age. I'm going to use it as the age, and then I'm going to use those values to create a separate independent cat object. Okay, so inside the clone, and now I'm going to end up with a separate cat object that has a separate memory location, and all these two cat objects have in common is just the same value for the name and same value for the age, and that's the what we call a deep copy, which is a separate independent copy of two objects. So, for example, like for the joke or content, inside the clone method, you want to create a deep copy of your content, you need to create a new content object with the same value as your instance variables, and then you just return it. Same thing for the joke, same thing for the object. So you need to create a new object with the same value as your instance variables. That's how you create a deep copy. Does it make sense? Are we good? Okay. What else? What else should I cover? I'm asking you. Should we start talking about JUnit? Yes. Oh yeah. So strings, as soon as you make one, you cannot change it. So every time, so for example, you say string s hi, and then with the same string, you just change its value to hello. You might think that Java is changing this one, but what really happens now, Java is going to go somewhere else, create a new string, and assign it to this one. So once you make a string in Java, we call them immutable. That means you cannot change them. So because of that, they always get passed by deep copy. So you really don't need to be worried about strings to have them as a deep copy. They get passed around by deep copy all the time by default. Yeah, but not all objects are immutable. Only strings. We also have some data structures that are defined immutable, but not all the objects are immutable. Yeah. Yes, but if any object is immutable, you don't need to be worried about getting a deep copy or anything. Yeah. Anything else? Okay, let's go over JUnit. Finally, the time. And we're right on time. We have 30 minutes, so we can actually do that. Okay. So the whole idea of writing a JUnit class is just an elegant way of testing things. Okay. It's just a more elegant way of testing things. Like if I want to test this dog class, let's forget about the JUnit for now. So if I want to test all my methods inside this one, so probably what I do here, I'm just going to add main method, and then I'm going to create a dog object. This is the ID and age, for example. And then for testing, since you wrote the code, you should know when you create a dog object, what values should be saved, for example, inside different instance variables. So the whole point of testing is that now let's just go check the value of those instance variables to make sure right values are saved inside those variables. So basically, by testing, as you're running your code, you want to make sure correct values are saved inside variables or methods are returning the right values. That's the whole idea. So for example, I can say, okay, let's just check if the ID, do I have ID here? Yeah, ID is inside the animal one. So if ID is equal to now this guy, so if that's the case, I can say system out print line correct. But if it's not, I can say system out print line failed. Something like that. Okay. But this is not the elegant way of testing things. So Java provided this library JUnit that we can use to actually test things in a more elegant way. Okay. And that's how it works. So basically, I want to create a new class here. I'm just gonna I don't have any projects set up or anything, so I'm just gonna do it in old-fashioned way. This is not the proper way of doing it. If you have a Java project set up, you need to add a new file under the SRC folder and everything. But I don't have those here, so I'm just gonna create a new class file here. I'm just gonna call it dog tester.java. Okay. So the first thing that you want to do in your JUnit, you want to import the necessary files that you need to deal with. And if you look, if you watch those videos that I shared with you that show you how you can set up JUnit, there is a JUnit library version 4 that you need to add to your project first. So there is some link in the instruction, both in homework 2, also in project 1, that shows you how you can install that. Just follow the instructions. I don't have any project set up here, so I can't really show you here. But let's say you add the JUnit version 4 library to your project. Okay. So now the next thing that you want to do, you want to import all the necessary classes. So the first one is going to be org, JUnit, assert, and all those assert methods inside this class. Why am I adding this static here? Because if I don't, every time I want to call one of these methods here, for example, assert true, I need to also mention the class name with it. So by just importing these classes as a static, I can just call the assert true method, for example. I can just call the method directly. I don't need to mention the class before it. Another thing is just going to be org JUnit before class and org JUnit test class. So these are the libraries that you need. And again, you just define a normal class. And probably you want to have some setup for your object that you're trying to define. So as an instance variable, you can just define some dog object here. And then I'm going to call it run. So and before every test, I want to make sure this method is getting run. So I just add this before clause to my method. So this is basically my constructor. Okay, this is basically the method that I want to get run right before running each one of those my test methods. So what I do here, inside this method is usually what we do inside the constructors. So I'm just going to initialize this thing with some values. So dog, some name, some ID, some like whatever the breed is, shepherd, and I don't know, like the age is 1.5. Okay. So that's what you do. So now this method gets run right before any tester method. How do you create a tester method? You just define a void method. That's one. And you want to make this one a tester. All you need to do, you just add this add test clause before it. And now this is a tester method. So the tester method either passes all the tests or fails. That's why it has to be void. It does not return anything. It either passes the test or fails. So now, since I wrote the code, I know what values are getting saved inside the variables and what values are being returned by the methods. So now you need to just come up with some scenarios. So for example, I already created this dog object here, which always gets run before my tester method. So now I know that I already have a dog object, so I can actually check to see, for example, if the name, if the ID is 121. And if it's 121, that means my constructor was working just fine. My constructor was able to assign the correct value to the instance variables. But for checking that inside the JUnit, we use assert methods. Assert methods also either pass or fail. And we have a ton of them. We have list of assert methods. The easiest one that probably you always want to use are assert true, assert false, and assert equal. It doesn't matter which one you use. As long as you use one of them, it's fine. So for example, I want to make sure the ID or the name of this thing is equals to df. Well, I'm going to call it, I don't know. This call is called Misam. Okay. I want to make sure the name is Misam. So I can actually, as long as this thing, they are equal. So now if I just use assert true, that means if that expression that I'm using, now this assert is passing the test. If it fails, that means this condition was not true, which means the name is not Misam anymore. Something is wrong. So that means now you need to go back and look at the code to see what you did wrong. What else do I have? Like, do I have more methods? For example, I can add something here. So I can add a method here. It returns a Boolean value and it checks to see if this guy is young or not. So return if the age is less than 2. Okay. So if it's less than 2, it returns true. If not, returns false. So I want to know if this one is working just fine. So I can create a new method. I'm going to call this testing is young. And then I can check to see, well, the age of this one was 1.5. So I know if I call the is young, this should return true. And if it returns true, this one passes the test. So that's it. That's the whole idea of using a JUnit test. You just basically, since you wrote the code, you should know what values are getting saved inside instance variables and what values are being returned by method calls. And then you just use this bunch of assert methods to just test them. That's the whole idea of using JUnit test. It's just a more elegant way of testing things. And you can share that with other people. The exact same thing that I did for homework too. I just gave my tester to you so you can test your code with, which is a nice thing to do. And all IDEs have some nice tools for it, so it shows you some visuals. And the coverage thing, it also shows you which part of your code you already covered as part of testing. I cannot run the coverage on this, but if I do, probably the constructor is going to be green, is going to be highlighted green, and this one is going to be also highlighted green. Everything else is going to be red, showing that I didn't have any tester, for example, to run this part of the code with. So the coverage basically shows which part of your code is already tested by some tester. It does not tell you whether or not your code is right. It just shows you which part of your actual code was already tested by some tester methods. That's all it does. So you want to make sure you're not missing like testing any specific part of your code in your tester. That's why you want to always go with more than 85% coverage, which means basically you tested majority of your code, not all of it. And in a real world scenario, like all these classes, some of them like have like 500 different methods. Writing a tester is going to take a long time. That's why all these big companies like have a separate department just for testing and everything. Does it make sense? Okay. I think that's it. These are main things that we need in this course. Hopefully I was able to just make some stuff clear for you. Um, is there anything else that I can explain? Yes. Great question. So basically, for instance variables are the part of your class that are holding very important data about your class. What we usually do, we define instance variables 99% of the time as private. So other people cannot have access to them. And because they are private, that means if in some cases you want to provide some of those, like the values that are being saved inside the instance variables, so other methods can call them. So in that case only, we add getter and setter methods. So now those instance variables are private. So now people can actually call the getter methods, and then they can actually use those getter methods to get the value from instance variables instead of having access to those instance variables directly. But there is a right way of doing it. Let me show that to you. So let's say I have an instance variable here. I don't know, the year. Okay, something. So this is a private. That means I do not want other people to be able to see it. I can provide a getter method for this. I can just say public int get year, and then I can return this dot year. Okay, are you following? So I can just do this. But look at this one. Like, this is a public method. Everybody can see it. And inside the public method, I am actually accessing the year directly. So that means everybody can see it. Everybody can see actually what I called my instance variables. So the right way of doing, like writing a secure code is that you add another private method. This guy returns the year, and then in your public method, you call your private method. Does this make sense? Now this is secure. So they can see what method I'm calling, but they cannot see what's going on inside it because this guy now is also private. So it's just for adding security for those getter setter methods if they implement it in the right way. They're just for adding security, for hiding things from other people. That's the whole idea of adding getter setter. Yes. No, you don't. You are provided a UML, so you have to follow the UML. So you don't want to have extra methods inside your class. But I just wanted to show you like what is the professional way of hiding things and writing a code that is actually secure. Yeah. Yes. Okay. So by convention, probably the only way that you should call your instance variable directly is inside the constructor. If you have getter method, everywhere else you want to call your getter methods. Okay, this is just by convention. It's not like if you call your instance variable in your clone method, it causes an issue. No, it's just by convention. Like these are some rules that programmers made up, like Java community made up. So and ask everybody to follow. So when you read another Java code, so you can actually follow it easier. That's the whole idea. Are we good? All right. Thank you for coming out. I'll share this video with everybody, and hopefully it helps other people. All right. Have a good night.